Hello, welcome along to a brand new Fun Kids Science Weekly. This is the show that snoops out all the science secrets that are lurking around the universe. My name's Dan. Thank you for coming back. Thank you for listening to officially the greatest podcast in the universe. This week, we'll talk about a shark that is so vicious, it hunts out humans anywhere. Also, you can hear about a brand new SpaceX rocket test that didn't go too well. And I'll answer some of your questions as well. Today they're all about the dinosaurs, about electricity, and phone vibrations. First, let's get some aliens back home, shall we? It's another episode of N&G.
N&G's Energy Challenge.
The human electricity is brilliant!
Well, I can see that. You're certainly making the most of it.
Look, I've got the telly box on, and the computer, and popcorn's ready!
Made a snack too? Look, come on! We're not going to find our way back to Zog sitting here. Let's find out more about electricity, like how it gets into these houses. I think we might need to go underground for this.
Aww, can't I just finish watching the telly? Just 5 more minutes!
All of the gadgets that you've been using get their energy through plugs that you've connected to sockets in the wall. Electricity is fed through these sockets, through cables under the floorboards or within the walls. And in turn, these cables connect up to even bigger cables under the streets. And there's nearly 14,000 kilometres of them! Ouch! We've hit a substation. Inside these buildings is equipment that changes the voltage of the electricity so that it's suitable to be used within homes.
Is this where electricity's made?
Nope, our journey isn't over yet.
Ooh, big metal trees!
Pylons. They're called pylons. The UK has over 7,000 kilometres of overhead wires carried between pylons. These power lines crisscross the country, carrying electricity to where it's needed. And it isn't just homes. Electricity powers trains and factories, schools and streetlights, and it all comes from here, back to where it started.
Where's that? The power station? Is this where electricity is made?
Yep, there's over 50 power stations across the UK. They're often found in the countryside or near the coast, normally far away from where people live. Electricity that's made here is a bit like a stream of tiny charged particles that are fed into those cables. Just think of it as a massive river running around the country.
Oh, right. And the cables carry the electricity all the way to people's homes.
You've got it. If somebody wants to use some electricity, they just take it out of the flow at the plug sockets.
Mrs. Bubcombe and Harrow just switched her kettle on.
Why is that a problem?
Well, it's a flow going around the country and she's got it going into her kettle. Everyone else will have to wait for their electricity. Hurry up with your copper, Mrs. Bubcombe.
That's not how it works. Electricity travels in an enormous loop. Some electricity will go into the kettle, but the rest just keeps going around the country until it's either used or returns to the power station. And then it all starts again.
As endless as the flowing lava over the most southerly Zogian snowcaps.
Kinda. It's got something in common with the lava flows on Zog, actually.
You mean the electricity comes bursting out of the top of the crag of Mount Oove?
Well, clearly not.
I suppose that would be a bit hard with Mount Oove being on Zog, 3 trillion light years away. Is it that the flow of electricity races down the ice pig plains on the 7th moon day of the equinox?
You're obsessed with those ice pigs. No, what I meant was the circuit of electricity can be very dangerous. It can even kill humans. You'll have noticed the big signs warning of the danger near overhead lines and around substations.
Well, however great this electricity is, there's no danger of it getting us home. Our laser pod needs something even more powerful.
You may be right. We'll have to keep searching. Watch out! Looks like we're gonna fuse, G!
Here it comes. Whoopee! I love a bit of fusion.
Here it comes! Woohoo!
N&G's Energy Challenge with support from National Grid. Find out more online at funkidslive.com/energy.
It's question time on the Science Weekly. This is where you send over a science question to me as a review on Apple Podcasts. I see it, I do all the digging, and then we see what we find out. Football Star has got in touch, who wants to know, how did the meteor wipe out all of the dinosaurs? Tricky one about this, Football Star, is that no one currently alive was around all those years ago. But we've done our best guessing. We've found out what we can. Now, scientists think that the meteor hit the Earth at a speed of 12.4 miles a second, 20 times faster than a speeding bullet. It generated a force of 1 billion times greater than an atomic bomb. It was the size of the Isle of Wight off the coast of the UK. It crashed in a place called Chicxulub in Mexico. Now, that meteor wasn't the only thing, like it didn't hit all of the dinosaurs who were in one place in this crater near Mexico. It actually set off a chain reaction that killed 80% of life on Earth at the time. It would have thrown a huge dust cloud into the air, which blocked sunlight, so most plants couldn't thrive and photosynthesized. If there are no plants around, there's not much other living creatures that need the plants to live. When it rained as well, acidic mud would have fallen to the ground. It would have caused a nuclear winter because the sun couldn't get through, followed by immense global warming. And over this time, all of that put together would have made the dinosaurs go extinct. Thank you very much for the question, Football Star. This is from Sam Fu on Apple Podcasts, who wants to know, how can electric go through water but not rubber? Now, water conducts electricity and rubber doesn't. It's all because of the ions that are in water. Ions are electrically charged particles, and there are loads of them in water. So when something hits it, like a lightning bolt, all of these ions, they line up pretty much to let the electricity instantly surge through the water. When it's a lightning bolt, it then instantly charges this water with millions of volts of electricity. Becomes a superconductor, hugely powerful. Now, electricity doesn't move through rubber because there are no free electrons in it. The particles can't move in a way that lets the electricity pass, so we call that an insulator. That's a huge topic, Sam. I mean, we could spend all day talking about that. That's just a little snippet of why electricity passes through one thing but not the other. Thank you for the question. And finally this week, this is from Louise up in Scotland, who wants to know, how do phones vibrate? Well, inside the phone, you've got a vibration motor. That'll help, won't it? It's a tiny motor. At the end, there is a small cylinder. When your phone buzzes, what's going on? The motor is switched on. It works, it turns, and then this unwinds the cylinder, which creates vibrations. And these vibrations flow to the outside of your phone, which make it buzz. So there you go. Very briefly, that's how phones vibrate, Louise. Thank you very much for the question. If you've got something sciencey for the show, you need to leave it as a review for us over on Apple Podcasts. It's the Fun Kids Science Weekly. This week, we're talking to a prize winner. Now, the Queen Elizabeth Prize for Engineering has set up a thing where designers could draw, design, create, make, inspire for the trophy that would be given for the world's #1 engineering accolade. Now, the person who designed the winning trophy is Hannah Goldsmith. She's on the line with us. Hey, Hannah.
Hi.
Well, first off, congratulations. Well done for winning.
Thank you.
Now, talk to us about the inspiration for the design of the trophy that you've made.
So when I started the process, I just did a Google search for engineering, and the first images you get are just the usual things you'd expect, like machinery and schematics, the very practical aspects. But on the second row, there's this really gorgeous image that your eye just gets drawn to, and it was of a neon circuit board. And it was when I saw that image that I was like, that is what I'm going to base my design on.
So I'm trying to describe the trophy that you've designed. It's it's like a circuit board rising from the base, isn't it? Made by what looks like, I guess, goldish, bronzy circuits. Is that right?
Yeah, that's right. It was just like kind of growing out of the base.
So what did you do after you had that initial idea, Hannah? How did you make what I've seen from what was in your head?
So I first had to look up loads of reference images to like inform my design. and I then drew it out on paper, like just rough sketches, and it all kind of just like came together on paper to start with. And I looked at it and I was just like, how am I going to get that into like the 3D trophy? And it has lots of branches coming off like the columns of the circuit board. And I realized that they'd all kind of like collide together. So I had to then kind of work out how to stagger them in order to get it into the software and create it, and then just build it from the plan I'd already made.
So you built it, physically built it?
It's in the software. So it's a bit like what I think of when I think of like Minecraft, how you have blocks and then you can you build the blocks up and create your designs, and you can rotate them and put them off at angles, and you've got like different shapes. So you've got like triangular prisms, cubes, hexagons, and dodecahedrons, which it's fun to say.
It is very fun to say. I am not a great designer. The thing that I see and I imagine in my mind, I can't translate it with my hands at all. What would you say is the most important aspects and qualities a designer can have?
Imagination. If you can imagine it, then it's like you can find a way to make it real. It's like, it doesn't matter if you don't think it looks great to start with, because nothing ever starts out perfect. You build it up and you refine it, and it will get to where you want eventually. And it's like that. Yeah, it's that perseverance, that imagination, the creativity, anything like that.
What designs in the world that we see really inspire you to keep going, to keep creating?
It's like works by this graphic designer called Chip Kidd. He does loads of book covers, and like for Penguin Publishing, the Random House, so they're worldwide. And one of them is the Jurassic Park logo, that like classic thing that everybody knows. And it's just like knowing that it's like someone can start off like really small and just in like design school or even just on their own, and that they can build up to something as big as that and have worldwide impact for just something very simple as a logo.
Now, you've won this award, you've made the trophy. What happens next for you? You're still studying, is that right?
Yes, I am. I'm currently in my second year at university.
So you're studying at Norwich University of the Arts. When that's all over, what do you want to do with the degree? What would you like to design?
So I'm doing a specialism called Design for Publishing, which is part of graphic design, and I'd love to go into book covers and design book covers, because I love reading and I love art. And I was just like, when I was picking my university course, I was just like, what do I want to do that combines both of them? Let's design book covers.
When you say that to people, that you want to design book covers, how many times do people say, don't judge a book by its cover to you?
All the time.
Yeah.
I love that phrase as well, though, so...
I think you're okay. I think everyone judges a book by its cover. Mm-hmm. So, yeah, come on. Well, amazing. Listen, congratulations on the prize. You can look up the incredible trophy that Hannah has designed. Just search, it's qeprize.org. Have a route around the website. You will find this, and it looks stunning, like something from one of those dystopian shows that you see on Netflix or something like that. It's really beautiful. Hannah, listen, thanks for joining us on the show.
Thank you so much.
Now, for today's Dangerous Dan, we're headed into the ocean to take a look at one of the most savage sharks in the sea. Now, we've spoken about quite a few sharks on the show before, but I think, racking my brains, this is probably the most brutal of the lot. The bull shark can grow up to 11 foot long. It can weigh up to 500 pounds. Honestly, it looks like the most sharky shark that you could ever imagine. It's got sharp, striking fins, grey silvery skin, razor-like teeth, So all of that makes them pretty terrifying anyway, and they've got this short snout that gives them their name of the bull shark. What makes them even more scary is that they thrive everywhere. Seawater, fresh water. They're known for travelling up rivers and canals too, and they're not put off by normal human things that might steer shark away. And with that, they are phenomenally aggressive. They come extremely close to the shore. They will take down anything to get their food. They are vicious carnivores. They're in the top 3 of sharks that attack humans, and they're also thought to be a prime suspect in attacks when scientists don't really know what the shark was. They're thought to probably be a bull shark because they travel so far into places most other sharks don't quite visit. They are brutal, aggressive, angry and hungry beast. So this savage shark of the sea, the bull shark, it has to go onto our Dangerous Dan list. Right, let's have a look at what's going on inside your body now. This is Professor Hallux's
Physiology Fix Up.
So, Hallux, you can tell me, are you disappointed that your inventions to improve the human body were all, well, physiology failures?
Not at all. Science is full of people who might not have got it right all the time. I mean, take old Hippocrates. Over 2,000 years ago, Hippocrates was a scientist. He was known as the father of medicine. He studied the human body and believed that all illnesses could be traced back to 4 substances, which he called humours. These were black bile, phlegm, blood, and yellow bile. Now, he wasn't right about humours, but he was one of the first to try and figure out how organs and systems work together. What he found out helped scientists who came after him. Things really took off a couple of hundred years ago when people started to understand cells and how they work with the body's systems. Joseph Lister used this knowledge to work out that many infections could be easily prevented by keeping wounds and surgical instruments clean. It seems obvious now, but it wouldn't have been possible without understanding the physiology of the blood. And we're still learning all the time.
Yes, learning that carrier pigeons, trained mice and sieves aren't a match for our body's organs.
Exactly. It's all knowledge after all.
I can't argue with that. So, tell you what, let's load up the physiology file one more time to find out some of the cool jobs you can do with physiology.
Loading physiology file. We might know a great deal about the way bodies work, but there's always more to learn. Many physiologists spend time studying living organisms to improve the knowledge we have. They might concentrate on cells, a particular organ, or a whole system in the body. That sort of work usually takes place in laboratories or in hospitals.
But they're not the only type of physiologists you'll find in those places, though, right?
Physiologists also work in clinics and hospitals to help diagnose problems. They use their knowledge to figure out what's gone wrong, maybe working with people who have hearing problems or those who have trouble breathing.
Now, I love being in my laboratory all day, but it's not for everyone. What if you like physiology but want to be out and about?
Some physiologists specialise in sport, working with athletes to help them get the most out of their bodies to run faster or jump higher.
So you could even help put the first human on Mars, to infinity and beyond, going farther than anyone has ever gone before, discovering strange new worlds in the outermost reaches of space.
Well, before we do all that, I think we need to clear away your inventions.
Good idea. Make some space right here on Earth. Do you get it? Space.
Very funny, Professor.
Hallux's Physiology Fix Up, with support from the Physiological Society. Find out more at funkidslive.com/Hallux.
Let's get this week's science in the news. A test of songbirds' problem-solving skills has shown that traffic noise makes their abilities to figure things out much worse. Experiments have shown that the sound of passing cars make it harder for the birds to find food. Experts think that birds communicate, kind of, where the food is, and they also listen out for signs of where it could be, and cars coming past and other sounds that humans make that much tougher for the birds. Also, SpaceX has launched another Starship prototype, and once more, just like last time, it failed to land. The uncrewed vehicle climbed to 6 miles up in the sky, then it came down to try and land in a controlled way near where it took off, but it didn't go too well. It slammed onto the launch pad far too fast, burst into flames, but no astronauts were on board, so don't worry, no one was hurt, and they say that they will get a huge amount of data from it as well. And finally, the European Space Agency, the ESA, will build more service modules for the US Space Agency's trip to the moon soon. These will push NASA's Orion capsule through space. It will also give life-supporting supplies of water and oxygen. And that is it for this week's Fun Kids Science Weekly. Thank you so much for listening to officially the greatest podcast in the universe. I'm so pleased. The trophy and everything, the certificate, that has finally arrived from Neptune. It's up in my toilet. Thank you very much if you have sent us well wishes for that. Now, one of the places that you can leave us a question to be answered on this show, is over on Apple Podcasts. Go to the review section, find the Science Weekly, leave us a comment at the bottom. That's where you put your question. Stick us 5 stars as well, and your name as well. That will really help me see it. While you're on Apple Podcasts, it's one of the best places that you can hear all of the science and other shows that we make at Fun Kids. It's on there, on the free Fun Kids app and at funkidslive.com. And Fun Kids, we are a children's radio station from the UK. You can listen to us all over the country on your DAB digital radio and over at funkidslive.com.